Now everybody stand back.
Is it gonna explode or something?
It might blow your mind, Amar, but no, it won't explode.
Gosh darn it.
Or maybe it will explode.
Yeah, all right.
Right, boy.
You see, when I mixed the substance in the beaker with the substance in the test tube, these were my reactants. A chemical reaction occurred. And when a chemical reaction occurs, new substances are formed that weren't there before. These new substances are called the products. Pretty neat, huh?
Not as neat as that explosion you almost promised.
Can we see another chemical reaction?
Why, certainly. In fact, there's one happening right behind me.
That's the bike you ride to school every day?
The one and only.
Why is it so brown?
Well, the non-scientific answer is I had to start using a hand-me-down after my last bike got run over by a plantain truck. Long story, taught to me after class. But the real answer is that the metal on this bike is undergoing a chemical reaction that is slowly producing rust. See the orange streaks?
Do we?
Speaking of orange streaks, hello!
Well, hey, Bunsen, how's it going? You enjoying my lesson so far?
It's fabulous! Just like your taste in original Frankel prints. Ooh! But you might be surprised how challenging this can be for students.
Well, I'm trying to keep things simple by not getting into the nitty-gritty just yet.
But that nitty-gritty is where it's at. Students tend to have a better understanding of chemical reactions when they're asked to explain what they see in terms of atoms and molecules. This can begin with teaching the concept of a substance. So instead of just saying that metal is producing rust, you might explain what makes up that metal. One of those things is called iron, made up of iron atoms. Give it a whirl.
Okay, class, let's see if we can, like my spinning instructor says, dig deep and put the pedal to the metal. Who can tell me the difference between an atom and a molecule? So, as I was saying, the metal making up this bicycle contains iron, which is made up of iron atoms.
Who are you winking at?
These atoms can undergo a chemical reaction that produces rust. I think they're really starting to get it now.
We're off to a grade A start, but we might be getting a little ahead of ourselves. Let's take a peep inside Amar's noggin,
These atoms can undergo a chemical reaction that produces rust. Okay, for the record, I'm much more graceful than that.
See, Amar is just starting to understand what happens with atoms in chemical reactions. But, as you can see,
Where'd those oxygen atoms come from?
well, he is right that rust is made up of more than just iron. But where did he think those atoms came from?
I realize now that I wasn't very specific earlier. I should have said, the iron atoms in this bike combine with oxygen molecules from the air around us to produce rust. I think Amar is on a good path, but I've seen enough to know that doesn't mean all my students have landed in the same spot.
Exactly the point I was just about to illuminate. Why don't we dive into Justine's perfectly shaped melon to see what she took from that?
The iron atoms in this bike combine with oxygen molecules from the air around us to produce rust. Oh, come on. Just for the record, my nickname in spinning class is the Viper. See, Justine's already thinking on the molecular level. Rust atoms? That's not a thing.
Neither are wallet-sized hadron colliders, but that didn't stop me from pre-ordering one just in case. Many students who hear about two substances combining imagine that they become something totally new, made out of different types of atoms.
I noticed that. Perhaps I can walk them through the chemical equation.
Whoa there, Speedy McQuickerson. That's some of the fastest chalkboard riding I've ever seen. Was that chalk dust or smoke?
Not too bad, huh? I feel like this will really help them understand what's happening.
Not so fast there, the Viper. I mean, talking about the chemical interactions from a molecular standpoint is a good start. And seeing the interactions written out can help, but it's definitely an abstract concept, and those symbols can be confusing on their own.
That's your solution? Marshmallows?
When aren't they the answer? Seriously though, having students use concrete visual models helps them to reason through how atoms rearrange into different molecules. You don't have any food coloring, do you?
Not on me.
Oh well. Not the most aesthetically pleasing, but it'll do. Now, using these brown marshmallows to represent iron atoms and these 3 red pairs to represent oxygen molecules, we can help show students how rust is formed. Breaking molecules apart and using the atoms from the reactants to build new molecules can really show students what chemical reactions are all about. And as a fun bonus, it also reinforces the law of conservation. Let me show you. Learning with concrete models can steer students into only building products from what they started with. Nothing more, nothing less. You don't happen to have any chocolate or graham crackers, do you?
It's with the food coloring.
Oh well.
Marshmallows seem like a useful and fun way to get my students to reason through these chemical reactions. But there's something about the atoms of that rust molecule sitting in a straight line that feels like it could be misleading. Rust isn't arranged like a falafel kebab.
Every physical model is going to have its limitations. The classic ball and stick models can certainly help give a better sense of how the atoms within a molecule are arranged geometrically. So when you're ready to talk about the details of chemical bonding, use that one too. Variety is the spice of life.
And I'll make sure to point out the strengths and weaknesses of a given model. It's good for students to be reminded that models are imperfect.
Well, not all models.
Mm-hmm.
Of course, you can reinforce these concepts of conservation and rearrangement by having students clearly define the system being considered. A common source of confusion is that all the reactants may not be obvious or accounted for. Like earlier, when Amar was viewing the system as consisting of only the bicycle. Help students reason that the air is made up of molecules and that those molecules can be reactants while also having them get in the habit of clearly defining the system they are considering.
Your suggestions are spot on as usual, Bunsen.
I'm glad you could match my enthusiasm. Fire pun. Hi-yo!
It might be time to dial back on the gas, my friend. But first, are there any more big misconceptions I should be on the lookout for?
Does hexane contain 14 hydrogen atoms? Of course, silly. One more pervasive misconception is the idea that chemical reactions are one-way streets, that all are completely irreversible.
Yeah, I think I know a colleague who still believes that. He shall go nameless, but it rhymes with Mr. Smolberg.
Ooh, you are bad, bad, bad. I love it.
I know. A lot of teachers still use the notion of irreversibility to explain the difference between chemical reactions and changes in state or phase. The erroneous rule is that physical changes are always reversible. A gas can go back to a liquid and back to a gas again, while chemical changes never are.
It's time we kick that rule to the curb.
Amen.
I think the misconception that chemical reactions are always irreversible also stems from the fact that many reactions are referred to in classrooms as, quote, going to completion. Ugh. In reality, most chemical reactions have a balancing point, not an end point. Imagine you're at the beach. Some people are going to be lying out in the sun or playing volleyball. Others are going to be in the water, swimming or splashing around. Sometimes people on the beach will get into the water, and some from the water will come out to dry off. But overall, the ratio of people on the sand to those in the water is about the same. It's not frozen. The system is in constant flux, but the overall picture is stable.
I gotta say, Bunsen, you were really...
On fire today?
I was gonna say helpful, but sure. Now, if you don't mind, I'm gonna get back to my students, but first... If you don't mind.
Oh, of course not. You want a golden brown or cremated? I prefer mine crispy exterior with gooey center, but some people like a uniform squishiness. Others like it burnt like a hot dog on the 4th of July.
Hey, science lovers. Subscribe, share, and like. See you soon.